Hydrogen fusion in the core of the Sun. This is also called a proton-proton chain. The Sun is a ball of gas, and under its own gravitational force, it would just collapse. However, the fusion energy produced in the core of the Sun keeps the Sun from collapsing. The details of the fusion are as follows. When two protons at room temperature approach each other, they repel each other because of their electromagnetic force. They're both positively charged. If two atoms approach each other at very high speed head-on, the speed needs to be a fraction of the speed of light. Now, when they get close enough, the gluons can be exchanged between them, and this will enable them to fuse together. The detail is as follows. Step 1, when two protons in the core of the Sun approach each other at high speed, they fuse together. One of them turns into a neutron and emits a positron and a neutrino. This is the very first step. So we just formed what is called a deuterium atom. Next, the deuterium atom in the core of the Sun will collide with another hydrogen atom. At this point, a helium-3 forms. Helium-3 has two protons and one neutron. A gamma ray photon is also emitted. So at this point, we have a helium-3 atom. Next, two helium-3 atoms, they collide head-on and form helium-4 atom. Two protons are also ejected in the process. Now, basically what we did, we transferred 4 hydrogen atoms into a helium-4, which is 2 protons and 2 neutrons. So, because E is equal to mc squared, or energy is equal to mass times the speed of light to the power of 2, that little bit of mass loss between 4 hydrogen atom and 1 helium atom has turned into energy. That's where the energy of fusion comes from. This page is diagrams of the entire process. 2 protons collide, forming deuterium. Next, deuterium collides with a proton. Helium-3 forms. 2 helium-3 atoms collide, and a helium-4 is produced.